All right, hello students. So one other type of differential equation is called a homogeneous differential equation. I've always heard it pronounced homogeneous for what it's worth, but I think it's very similar to homogeneous, but I'm going to call it homogeneous. Anyway, the idea with homogeneous is that if you can write your differential equation as a function of y over x, you can use a substitution to solve it. And so I'll just do problem one as an example, 1a. If you look at the original problem, it's not really a function of, uh, of y over x the way that it is written. So if we divide everything by x, then we will get where we want to be. So let's divide everything by x. And that means that now we're saying x cannot equal 0. So we're saying y prime equals x cosine x plus y over x. And then we use this substitution where v equals y over x. And so if you have v equals y over x, that's the same as saying vx is equal to y. And so if I take the derivative of both sides of this substitution, then I get my derivative of v times x plus product rule plus v times 1 equals dy dx, so y prime. And so I can make that substitution and also make the substitution over here. So this piece is going to go to the left side. And then I'm going to also substitute v for the other piece there. So we have v prime x plus v equals x cosine x plus v. That's great. So then let's subtract v from both sides. And we have v prime times x equals x cosine x. So then let's divide everything by x. Divide everything by x. Again, v prime equals cosine x. Therefore, by integrating with respect to x, you have v equals sine of x plus c. And then we're just one step away. If v equals sine of x plus c, v is equal to y over x, right? So then we have, I'm going to go over here to the left, y over x equals, that's weird, y over x equals sine of x plus c, multiply both sides by x, and you get y equals x times sine of x plus c. I want to point out we did make the assumption that x cannot equal 0 throughout this problem several times. If x did equal 0, then you would also have that y has to equal 0. And you can see that by looking either at the original differential equation or at our solution right there. Okay? So now just to verify and be a good little math student, if I take my answer, I should be able to substitute it back into the original problem. So I'm going to give myself a little space to do that. So I should be able to substitute that back into the original problem. Looks like I need to calculate y prime. So let's use purple. So y prime, using the product rule again, would be 1 times sine x plus c plus x times cosine x. That's the product rule. And so to rewrite the original differential equation, we're going to do x times y prime. So x times everything I just wrote. I guess I don't need to write the sine of x, or the 1 in front of the sine of x. So x times sine of x plus c plus x cosine x. That's the left side of the differential equation, equals x squared cosine x plus y, x times sine x plus c. So I'm just verifying, just like we verify back in Algebra 1, you plug it back in. And now we just need to make sure that the two sides of the equation are equal. So let's just distribute on the left side. We get x sine x. Come on, work with me. X sine x plus x times c plus x squared cosine x, that's the left side, and the right side is identical. Here's x squared cosine x, that's great. Here's x sine x, and here's xc. So we know that it was right because we substituted it back into the original differential equation, and the left and the right side were equal. So that's an example of a homogeneous differential equation. You do this substitution of v equals yx. Just like when we do u substitution, you also go through and calculate what y prime is, and you go from there. All right. Thanks for watching.